we will be starting with the architecture and organization of the computer, like how the computer is made up of and what different components constitute to a computer system, and these different systems, what these different systems basically does into a computer system to get the particular output from a computer. Okay, so basically we will be starting with organization and architecture. So basically our course title is computer architecture and organization. So what this architecture stand for and what this organization stand for, we will be just going through that and then starting with the content. So here computer architecture. So basically computer architecture is like system is there. So any system, if we talk about, it is made up of different building blocks. Okay, so different building blocks will be there. So these building blocks are going to constitute to a system. This is complete system is there. So this is block 1, this is block 2, block 3, block 4. Okay, so these blocks are considered to be the different components of this system. And these components will be having some functionality or will be operating such that this system will be generating some output with respect to some input given to the system. Okay, so this is a system, we are giving some input and we are getting some output, and these blocks, these building blocks are going to coordinate with each other to get some output by performing some operation on the inputs. Okay, so these building blocks are considered as the architecture. Okay, so inside a computer system, different architectures or different configurations are there. So these configurations will be considered as the computer architecture. So basically it is different blocks are there. These basic blocks will be like, these are the attributes to a system visible to a programmer. So if a programmer is there, if a programmer wants to have suppose a plus b, okay, so the programmer should be knowing like inside this system there is a register or a memory location R1 and another memory location R2 or register R2. He need to put A into R1 and B into R2, and then the programmer will be writing the code to perform R1 plus R2, and then the output will be generated. Okay, so the programmer should be knowing the inside blocks of the system. Okay, so these are like the visible blocks to the programmer, or in other ways we can say like it is these blocks are basically the blocks that are going to impact the output of the system, or after performing a particular operation, whatever the result will be there, that will be governed by these building blocks. Okay, so here these attributes that have a direct impact on the logical execution of the program. So a program that is a plus b we are going to execute. So a plus b execution needs the particular blocks of the system. So these building blocks will be called the architecture. Okay, the next we will see what is computer organization. So here different building blocks are there, and these building blocks, how they are communicating with each other, will be considered as the organization, or this is like this basically refers to the operational units. Different operational blocks will be there and their interconnection. So different building blocks and their interconnections that basically realize the architectural specifications. Like if a system is there, different building blocks are there, or different components are there. These components are connected with each other, or these are organized in a specific manner so that it should be generating a particular output with respect to a input. So the organization refers to the interconnection of these building blocks. Okay, so here in computer architecture and organization, what we are going to do is, first of all, we are going to study these blocks. Okay, how these building blocks are look like, and how or what particular advantages and disadvantages these blocks are having, and then how they are interfacing with each other, how they are connected with each other, and internally inside this particular block, what particular operations is taken place to perform the complete function of the system. So here in computer architecture and organization, we are going to deal with this only. Okay, so you can correlate with all the theory part that we will be going through. You can correlate with your computer systems that we use in daily life, and also the mobile system. So all are the part of the computers only. So you can have the correlation. So here in this course, basically we are going to have is like what we can get from this course is what computers consist of. We will be going to know this, and how computers basically works, and how they are organized internally, what are different blocks are there and how they are organized. What's the design trade-off? Design trade-off in the sense like here design trade-off means if suppose uh, first of all there are different design parameters are there. So suppose in terms of computer we are having speed. Speed is one of the uh, performance parameter, and the area requirement, or we can call it size. Size is one of the uh, performance parameter. Speed, area, and the battery life right now. So different performance parameters are there. So we should be having a trade-off. Trade-off means suppose a application is there. We are having an application where we want results within a seconds. Okay, so here some applications are there where speed limitation is there. Like we need to have the operation performed by the system should be in very less time. If the speed limitation is there, we should be preferring, or we should be designing this system so that it should be having lesser delay, or the execution of instructions per second should be higher in that particular application. If some application is there where area requirement is there, suppose a mobile phone is there and a laptop is there. So laptop takes larger area and mobile is having smaller area. So in terms of mobile, it is also a type of computer only. So in mobile, we are requiring less area. So if we are requiring less area, we should be getting some of the functionalities in terms of speed. We can have speed lesser than the laptop, because laptop is having higher you can say area requirement, and also once it is higher area requirement, we can build larger processors onto this larger area. So the speed of the laptops would be high, or speed basically laptops are having better speed. And in terms of mobile, the processors that we will be implementing or battery requirement, based on that, these are the different trade-offs are there. That means if we need a particular application where less area is required, we will be limiting its speed. So if area is small, so small area is there, then speed will be slow. Okay, so in terms of like here laptop, if larger area is there, speed will be high. Or in terms of desktop, you can consider, so desktops are basically having higher area, and they are more, you can say, performance oriented. They have better speed and better performance in terms of mobile or laptop. Okay, so here one thing we can see is if the area is large, the performance is high. Okay, or if area requirement is large is there, area is having a limitation here, but the speed is advantage. Similarly here in terms of mobile, area is small and speed is slow. That means area we are utilizing is less, but the speed is slow. So somewhere we are compromising with either here in terms of desktop, we are compromising with the area requirement. In terms of mobile, we are compromising with the speed. Okay, so this is called the trade-off. Based on the application, we are doing the trade-off. So design trade-off we will be knowing. So based on the architecture, based on the system performance, we can know like what different trade-offs we can do to implement a particular system. So here the next point is how design affects programming and its application. So basically programming, we will be seeing the assembly language programming, like how we basically gives instructions to the computer, like instructions in the sense like we are going to give some inputs to the computer in the sense microprocessor. Okay, so we are going to give some inputs in terms of programming, and with respect to that we will be getting some output. Okay, so here how the programming affects the design and what programming basically uh, gives different design, and with respect to particular design we are having different applications. So design is going to affect the application. So once application is different, we will be using different design. Okay, and different type of programming also. So this all we will be going to deal with into this course, but what we will not be getting into this course is like how to fix a computer. We are not going to study this, like how we are going to fix the computer or how to build myself one real cheap computer. We are not going to do that. Which one to buy based on like we are not going to recommend like which you should be buying the laptops. But yes, once you know different basic components, you will be able to identify which one is better and which one is not. Okay, and also like knowing all about. So basically, we will be focusing on a particular computer system. We will not be going to a particular processor like either it is 8085 or Pentium or Core i5, i3. So we are not going to study deep into that processor, but we will just know like what basically the processors are and how the processors take decisions to give some output. Okay. So next one is a computing machine. So any computer system is there that is considered as the computing machine. Okay, so there are different types of computer or different types of computing machines. So we will just see it. So these computing machines can be of different types. Ubiquitous means that is its property will be same for everywhere. Okay, so there are different types of computing machines. So suppose a general purpose machines are there. So these general purpose machines can be like servers, desktop, laptops, PDA, okay, etc. And a special purpose in terms of like cash registers, ATMs, games. So these are all the machines, okay, or in terms of like the computer machines basically. With the help of some computing device, it is going to give a particular output or going to perform some particular operations. Okay, so some embedded devices are there or embedded machines are there, like embedded into the car. Okay, so embedded chips are there, like controllers or even the processors are used. Microcontrollers are used in hotel doors to take the decision based on the input, and the printers are having different decision making machines and different industrial machinery and medical equipments. So all are going to use some type of machines. Okay, so based on the application, the machine complexity and machine simplicity or design will be different. So how we should be proceeding with different machines, so that is a different point of view. So here basically we are going to see like there are different types of machines, but we will be basically focusing on a basic computer machine, like how it works and what different components are into that machine. Okay, and its characteristics. So all these machines basically have some characteristics. So the characteristics are given by like the speed and also the cost and ease of use, like is it difficult to use or easy to use. That also is one of the characteristics. So suppose you are having Windows OS, Windows OS and Linux. So in terms of Windows and Linux, most of you basically prefer Windows because it is easy to use. Okay, but Linux is somewhat like only those persons going to use Linux that are familiar with the programming and familiar with the coding and even familiar with some basic commands, like how they need to use the terminals, how they can use uh, they can perform different operations through terminal. So then those only basically go for using the Linux operating system. But Windows, everyone can use. It is easy to use. Okay, so that's it all. That's it. Based on the ease of using, we are going to recommend a particular system. Okay, so here the characteristics is going to define is the ease of use also. So ease of use is one of the characteristics, and software supports and interfaces, like how the interfacing is there, what different software supports are there. So there are different iOS are there. Okay, so in iOS basically uh, the software supports are very limited, but in Windows or in case of like mobile operating system, Android is there. So in Android, there are a lot of, or you can say very rich application source are there. So that's why this Android are most frequently used and iOS is very less used because it is having very less uh, software support. Okay, in terms of like its store, whatever application store is there, that is not having that much of application. But here in Android, it support lots of applications. So Android users are very in large quantity, and also the scalability. So in terms of scalability, any system is there. If a system is there that can suppose uh, version 0.1 is there or 1.0, 2.1, 2.2. So there are different suppose versions of a particular system. Okay. So if a particular, suppose this is the version, and by adding something to this version, we are able to get 1.0 version, suppose. So that means we can say that this system is scalable. Okay, because what we are going to get is from the previous version with some modification, we can get the new version. That means this version was scalable. So this should be the property of a particular device. So if it is scalable, that will be more demand in the market. 2 points we are going to consider here: the abstraction, like what is an abstraction is there, and the difference between hardware and software. So abstraction is basically here is like suppose we are going to study some topic. Suppose we are going to study the computers or computer organization. Okay, so we are going to study CAO. But before going to study CAO, we should be knowing the basic components of the computer. Okay, and also once we know the CAO, what we will be able to do is we will be able to like implement this computer system for different applications. We can use this computer system knowledge to design, okay, design a system. So based on our CEO knowledge, we will be able to design a particular system. Okay, so here there are different levels. Okay, so this is one level. After this, we study CEO and then we are able to design a particular system. So abstraction is basically, if we are going to study CAO, we should be knowing prior to this what basic components are there to the CAO and also next to it. So abstraction levels is basically uh, going to simplify your step. Basically, it is a step. Okay, abstraction is basically a different steps that basically simplifies the a particular operation. Okay, so here in terms we can just see the definition. So here it basically one level of a big picture at a time with the confidence that we can then connect effectively with the levels above and below. That means at what particular level we are here at this particular level. Once we are here at this particular level, we will be able to connect with components also, and we will be able to connect to the design of a particular system. The abstraction level is basically a level that basically simplifies different uh, levels. So whatever we are having uh, above that particular level and below that particular level, we will be able to get the knowledge of that. So abstraction level are basically defining or basically simplifying a particular steps. Okay. Framing the level of abstraction appropriately is one of the most important skills in any understanding. So in terms of like uh, computer design, or in terms of suppose we are having some algorithm. So in once we go for writing a program, we write an algorithm. So algorithm is, suppose algorithm is step 1, then step 2, then step 3, and then step 4, like that. There are different steps into an algorithm. Okay, so if there are different steps, so these steps can be considered like abstractions. So if after this step this would be there, after this will be there. So this suppose third step is there, it will be related to 2 and also related to 4. Okay, so this abstraction basically simplifies the operation. Okay, and make appropriate arrangements of these steps so that we will be getting some output. Okay, hardware and software, basically here uh, abstraction does not mean being clueless about the neighboring levels. So it is like different neighboring levels are there. So these levels are there. So it will not be like after step 2, this step 3 will not be related to either 2 or 4. This should not be there in terms of abstraction. In particular, hardware and software are inseparably connected, especially at the level of level we will be studying. So here we will be studying the architecture as well as the organization. So architecture will be in terms of the hardware, like how on what particular components we are going to use to run a particular block of the system. And then once the different blocks we have got, how we will be connecting these blocks, that is in terms of like some relation. So that relation will be like in terms of hardware and software relation. So what is computer organization? So here in terms of the correlation, we can just say here suppose any system is there. So that system is made up of electronic devices. Okay, and we have electronic device and we want to perform something so that we can get some desired behavior or desired output, you can say, consider. Okay. So here, so in terms of electronic device, and then we want some behavior. So it's not like an electronic device is there, a transistor is there. You can directly give some input and you will be getting output, what desired output you are uh, supposed to get. Okay. Here, before getting a desired output, we should be doing something on these electronic devices, or we should be making some connections, or we should be using some relations so that we can get the desired output. Okay. So this gap between electronic devices and the desired behavior is basically overcome by a general purpose computer. Here, what we are going to do is different electronic devices are there. We are going to organize it. Okay, we are going to have a computer organizing. Once we will be organizing these computer, these components, electronic devices, we will be getting general purpose computer. So once we have got the general purpose computers, with the help of some softwares, we can get the desired output. So suppose we are having a general purpose computer. On that, we want to have a PPT or we want to display PPT. So a general computer is there that we will be installing Microsoft PPT software, okay, or Office software. In that we will be having the PowerPoint presentation software. On that we can do our PPT. Okay, so we are having a general purpose computer. On that we will be requiring a software. This is a software, and with the help of this software we are going to get the desired behavior or desired output that is given. So we are having electronic device. We will be organizing these electronics devices so that we will be forming a computer, general purpose computer. On that general purpose computer we will be installing some software. We will be having some software, and that particular software will be giving us our desired output or desired behavior that we are doing. Okay. This is a typical structure of a central processor unit. So one of the CPUs are called the heart of a computing system. So in terms of computer, CPU is considered as heart. That means once inputs have reached to the computer CPU, it will be doing everything. So CPU is going to do all the mathematical operations or different logical operations to get our desired behavior. Okay. That's why the CPUs are considered as the heart of a computing system. And this is the structure or figure representing a microprocessor. Okay, so on this, like central processing unit, this much is the size of central processing unit. On that, this much small circuit a component is called the problems are basically defined by different level of abstraction. So abstraction will be nothing but the level just to simplify the particular problem. Okay, so we are having like a device is there, electronic device is there. With respect to this electronic device, we are going to make a circuit. This circuit is going to give an architecture. This architecture will be a machine architecture. On this machine architecture, we are going to give some program, and with respect to this program, we should be having an algorithm, and this algorithm will be based on the problem that was in natural language. Natural language in the sense like we were requiring to have an addition a plus b. So addition of a plus b is the problem in natural language, but with respect to that we are going to have an algorithm. Okay, with respect to that algorithm we will be writing a program. This program will be given to a machine architecture, and this machine architecture will be having some smaller building blocks, micro architecture, and these building blocks or micro architecture will be made up of logic circuits, and these logic circuits will be made up of some electronic devices. Okay, so here electronic devices can be like previously it was vacuum tubes, now it is ICs or transistors. Okay, transistors are ICs. Okay, so these labels basically do not necessarily corresponds to a discrete component, but to well-defined standard interfaces. So these are like not a random steps we have put here, but it is the steps that are correlated. So these logic circuits are related with the devices and related with the architecture. This microarchitecture related with the machine architecture and like logic circuit. So similarly, there is a relation between each. That's why it is called abstraction. So abstraction means what particular level will be having some relation with the upper one and the below one. Okay. So program level that we have already seen like how the programs basically work. So most computers are run on a management program called operating system. So all the computers will be running on a management program. So that management program is considered as the operating system. Okay, an application program. So an application program interface to the machine architecture via the OS. So if we are installing a particular software on a particular operating system, that application or that software will be considered as a application oriented program. Okay, so we wanted to have a PPT. So for PPT, we need to install the Microsoft Office. So this MS Office is an application software. Okay, and this operating system, this will be running on an operating system. Okay, so an operating system on which application software will be or application program will be run. So these two are nothing but the programmer software. Okay, so for example, yeah, this is the same example, like this is a particular lecture or we are delivering through Microsoft application. So this is a data that we want to display through a particular application that is called uh, PowerPoint presentation, and then it is running on a particular software that is Windows XP or Windows 10. Any operating system can be there. Okay. Yes. So machine architecture is the architecture. Basically, this is the formal specification of all the functions a particular machine can carry out, known as the instruction set architecture. So whatever the architectures we will be studying, that will be the instruction set architecture. So we will come across this point later into the lectures. Okay, and microarchitecture. So microarchitecture is like implementation of instruction set architecture in a specific CPU. That is the way in which the specifications of ISA are actually carried out. So here ISA is instruction set architecture, but this ISA will be consist of different smaller building blocks. That smaller building blocks will be considered as the microarchitectures. Okay, so we will just see into the later classes also. Okay, so logic circuits, so another machine level like uh, logic circuits. So logic circuits are different uh, functions or logic gates we know. So if a logic gate is there, suppose AND gate, OR gate, or different gates are there, these logic circuits are made up of different devices. These are called transistors. Okay, so logic circuits are these are the logic circuits. Okay, and these logic circuits are made up of different devices. So these different devices will be like transistors, or CMOS and NMOS or gallium arsenide are different transistors. Okay, so this was just the introduction to like basic basics of computer. We will just go now with some deeper knowledge into this architecture and organization part. So here we will come across like if a computer system is there, it is basically made up of different building blocks, and these building blocks are like here. First of all, it will be having a CPU. So it is having a CPU. Then there will be some input and output device. So in this CPU, we should be giving some input and we should be getting some output. So for that, we require input output device. And also while performing some operation, these microprocessor or CPUs are basically going to take some data and store some data. Okay, so they are going to store and take the data from a particular location that is called the memory. So we need a memory also. And also in terms of like when these are the individual blocks, input output, main memory and CPU, these individual blocks should be communicating with each other with a system of buses. So this is called system bus. So system bus means the bus or the connecting lines of this system. Okay, that is connecting each and every building block of the computer system. Okay, so this is the main building blocks of the computer system. Now further, if we talk about the CPU, if we go deep into this, there is control unit. Another one is execution unit. Control unit is there. It will be controlling like which instruction to be fetched next, and once it is fetched, where from where it is stored, it should be fetched, and once it is fetched, what particular operation it should be operating. That is basically, so control unit does is fetching and decoding. So any instruction is there, that each instructions are having different steps. So one is each instruction is, first one is fetch, another one is decode, and then third one is execute. So CPU They are the main building blocks. Then further we can just see is like in the CPU, some temporary memory locations are there. So these temporary memory locations are called registers, and temporary storage of the data is done by the registers. So all these individual blocks are combinedly connected with the internal bus. Okay, so this is inside a particular CPU. If we further take, this is the control unit. Control unit, if we go deeper into the control unit, this control unit will be having this type of components. So here, sequencing logic, control unit, register, and decoders. So here, decoders are there. Here, control memory is also there. Okay, so these are the different components of a control unit. Okay, so system or a basic computer system consists of these input and output, main memory, CPU, and these three components are basically connected with each other with the help of system bus. So even this system bus can be of different types. So we will see that also. And in terms of like CPU further classified into different basic building blocks or microarchitectures we can consider it. So registers, ALU, and control unit, and these are connected to each other with respect to an internal bus, and this control unit is consist of this. Okay, so this is all about the computer components of a computer system. In terms of like arrangement, we can arrange it further like here. CPU is there. CPU. Now that general trend that we see is here. There are different functional units. So this is how we represent a basic computer system. We will be having a CPU and memory and input output devices. So here input output devices are. So in terms of like input devices, we are having some input devices and some output devices. So these input output devices are nothing but the peripherals, we call it. So any component that is connected to a computer system, external component we are going to connect are considered as the peripherals. Okay, so here, so sometimes like if it is written as a peripherals, that is not a different thing, that is nothing but the input output devices. So it can be in terms of like input output devices, that is going to give input to a particular system, that will be considered as the input device. So in terms of peripherals, you might have known like there are different 8255, 8251 or DMA, a component is there that is called direct memory access. Okay, this is direct memory access. So these are called the peripherals. So also in terms of like if 8255 is there, 8251 is there, there are different components, peripheral components. Or DMA is there, it is 8257, it is called 8257. So this is IC, a separate IC is there that is basically used for direct transfer of data from one particular peripheral to another particular peripheral, or from memory to a peripheral. So there is a, suppose a peripheral is there. So if we want to have a memory transfer between two peripherals or between peripherals and a particular memory or memory of external memory. So what happens? So basically in terms of direct memory access is a external device. DMA is external device. So basically the data transfer will be done by the CPU or the processor with respect to the data bus. Okay, so in the previous figure here system bus was represented, but here we are not representing the system bus. So we can have like this is just a functional units are there, how they are combining it is not given. Okay, so there will be some connection between these building blocks with the help of system bus. Okay, so when a data transfer need to be done, basically the processor is going to process, because whatever instructions we write the instructions to the processor, like instructions like add or like move. So move a comma b, suppose this is given, that means we are going to move the data of b into a. We are going to move like that. Okay, so if we are going to move from a to b, the processor will be transferring the data from location or register b to register a. Okay, so basically the processor does the operation, but suppose a large amount of data is there that need to be transferred between a peripheral and a memory device. What we do is, basically, instead of processor, we use external device that is called DMA, direct memory access. So DMA, why DMA is used? Because in terms of like speed, if you talk about, the processor is having the speed in terms of gigabytes. Okay, sorry, in terms of speed, that is gigahertz. So 2.7 gigahertz speed are there in terms of processor. So processor is having this much of speed, but in terms of external memories, they are having very less speed. Okay, even the external peripherals, whatever the peripherals are having, it is having very less speed. So if data transfer is going to be taken place with respect to a processor to a particular peripheral or to a memory location, because it is having very high data transfer rate, but it is having very less data transfer rate. So because of this speed variability or speed difference, and this difference is very large difference is there. So because of this difference, if processor is going to transfer the data, it will be like we are going to uh, waste the efficiency of this CPU, because it will be transferring the data at the speed of the peripheral itself. Because if it is transferring with 2.7 gigahertz, the peripherals will not be able to get that data, because peripherals are not having that much of capabilities. Okay, so because of this difference of speed capabilities, a third party device is used to transfer the data between low speed devices. So low speed devices in the sense like other than the processor. Okay, so if large amount of data need to be transferred between the low speed devices or peripheral devices or external memories, we use the DMA. Okay, so DMA is also considered the peripheral device or a third party device. Okay. So this is the basic units, functional units of computer system. Okay, so just we will go one by one, like what these functional blocks are there, their uses and different advantages. So how the information is basically handled by a computer, we'll see. So here instructions are there, or different machine instructions or instructions are there. So information is basically transferring of information is basically this is governed by different instructions that is given to the computer system. So here the information will be in terms of 0 and 1. Okay, so all the information will be in 0 and 1, and even the instructions that we are going to give, that will be we are going to use assembly language here basically. So we will be going through this topic later into this class also. So assembly language is the language that is called low level language. So low level language are the language that are platform dependent. Platform dependent in the sense operating system dependent, or the machine dependent, you can consider it. So we are having like assembly language programming. On that we will be giving some input to the microprocessor, and this assembly language code will be converted to a machine understandable code or machine language code, or that is you can consider it is like object code, you might be knowing. So once a code or a language that is understandable by the machine only, that is called object code. So that is done by assembler, like a compiler. You know the compiler is, if different high level language are there, that is converted to low level language, like in the form of object code or dot object file, that is done by the compiler. Similarly, in terms of like assembly language code is there, if we are going to convert into the object file, we will be doing it with the assembler. Okay, so here it basically governs the transfer of information within a computer as well as between the computer and the input output devices. So here these instructions are going to basically govern the transfer. This is specify the arithmetic and logic operations to be performed. Okay, so here data in terms of like this is data here we will be using is as an operand. We will be using operands. So here like we were saying add a comma b was there. So it means we are going to add a and b and going to store a and b into a. So we are going to add a and b and storing into the a. Okay, so these a and b are called operand. So these are so a and b are called the operand. So data will be given in terms of operand. Okay, and the source programs are basically encoded in the form of zeros. So for user understandable, these are called the assembly language. So by assembly language uses the mnemonics. So this add is considered as the mnemonics, and with respect to that mnemonics, we will be just once we see the add a comma b, we will be understanding like it is going to perform the add operation. But this add a comma b in terms of machine language or machine instruction is represented in terms of only zeros and ones. So this is basically converted by assembler and it will be converted, and then this 0 and 1 representation of a add a comma b is called the object code. Okay, so here encoding will be done. Yes.
So what is the use of mnemonics?
Okay, so mnemonics is like, suppose we have previously done that also, like we are having some instruction add a comma b and then move a comma c. Suppose this is the instruction. So in assembly language, if we are going to represent a particular operation, we add some extra words or we add some words that are like uh, basically used in natural language that we use, like an English is there. So in terms of English, when we write add. Okay, so or if someone says you like add a comma add two numbers, so once you understand add, you will be going to adding the given two numbers. Okay, so these mnemonics are the words that basically represents the operation that processor is going to perform. So these mnemonics will be in terms of a user understandable words. Okay, suppose we are able to understand the English, अगर हमें इंग्लिश समझ में आ रही है हम क्या करते हैं, इंग्लिश में हमने वर्ड लिखा ऐड. सो अगर ऐड की जगह पर समझ लिख दिया ए बी, सपोज ए बी सी लिख दिया हमने, इंस्टेड ऑफ ऐड वी हैव रिटन ए बी सी ए कॉमा बी. So with this instruction, if a third person sees it, it will not be understanding like what this is all about. But instead of ABC, we have written add, then A comma B. So even if he does not understand like it is going to add A plus B into storing into C or storing into A or where it is going to store, but he will definitely understand like it is written add. That means we are going to perform add operation on what particular operands are there. That's different thing. So it is like with respect to this word, we are clearly going to get like we need to add the operand. Okay, so here mnemonics are basically used to represent a particular operation that a computer is going to perform, but that particular operation should be understandable to user. So this mnemonics is a user understandable word, English word, that is used to represent a particular operation of that is going to perform by the process. Okay, so mnemonics हम यूजर को अंडरस्टैंड होने के लिए वर्ड्स एक वर्ड यूज करते हैं, ठीक है। सो वो वर्ड ऐसा वर्ड है जो हमें देखते ही समझ में आ जाए कि हमें ऑपरेशन क्या परफॉर्म करना है। ओके, सो
Okay, sir.
that is called mnemonics. Okay, so in terms of assembly language programming, we will be using these type of instructions. So this is one instruction, add a comma b. It is a one instruction. Similarly, there are different instructions. So these instructions, each instruction will be having some mnemonics. Okay, so these mnemonics will be a user understandable or human understandable words that will indicate like what particular operation this instruction is going to perform. The next one is uh, memory unit. Basically, memory unit, what it does is, as everyone knows, memory, what it does is it stores the data, and data, basically data. It will be storing the data, and that data can be either actual data will be there, or it will be a program. So even I told you like some instruction is written, and this instruction will be written not in terms of mnemonics, but it will be written like add a comma b. It will be written in terms of add a comma b, and or you can call it like move b comma c. It will be written like that, but into the memory it will be written in terms of zeros and ones. So for add there is a particular code, for move there is a particular code. Okay, this is not, this is just I have written the symbolic one, but for each instruction, like for add there is a particular code into the binary, for move there is a particular code into the binary. So these codes are basically stored. Suppose this is the code, or suppose the code is of 8 bit. Suppose each location is going to be 8 bit. It is going to store 8 bit or 1 byte. Okay, so suppose this is 0000, so it is 0, and this is in binary. In hexadecimal, if we consider it is 0, and this is 5. So 05H is their hexadecimal, and this is like here 000. In hexadecimal it is 0, and this is 6. Okay, so it is like it is 05 and 06. So 05 and 06 will be stored at a particular memory location. So this is a memory. Memory will be having different locations. Suppose this is a location. At this location there will be 05. It will be stored. 06 will be stored, and this is having some address. It is the address. Okay. So it was an instruction, but once we will be converting it into object code, it will be like an traditional number or 8-bit number. 8-bit number in terms of hexadecimal, we have written 05, or we can write 00000101. This one, or 00000110. So these instructions itself are the value. Okay, you can consider it 05 is a value. In terms of if it is stored at a particular location into the memory, it will be considered the value itself, but it is a program, because add this is going to be represented by 05. So basically memories are going to store a data as well as the program also. Okay, it is going to store the data as well as the program. I hope it is clear. Okay, and also here
Yes, sir.
these memories are classified into different classes. So different classes can be like primary memory, primary storage, and another one is called secondary storage. So a primary and a secondary storage. So this primary storage are considered as the fast one. Here in primary storage, programs must be stored in memory while they are being executed. So basically, these memories are divided into two different sections. So one is primary memory, another one is secondary memory. Primary memory means, first of all, everything will be stored in terms of computer system. If we talk about the hard disk, HDD that we are having here. Even the program is also stored and the data is also stored. Okay, but this is the example. This HDD is hard disk is considered as the secondary memory. Okay, the primary memory, what is it? Is RAM. RAM or cache memory. These are the primary memories. So what happens? Suppose a microprocessor wants to execute a particular instruction, and that instruction is basically stored in HDD, that is hard disk, and that hard disk is secondary. So here it is stored. So here it is having program as well as the data. So when the processor going to start execution of a particular instruction into this program, it is going to fetch a particular instruction. Once it is going to fetch from the secondary memory, it will be storing into the primary memory. So it will be storing into the RAM. Further, if we talk about the hierarchy, this is the secondary memory, here the RAM, and here the cache memory here. So based on the hierarchy, just we can say, so hard disk is having, always you can consider like in basic laptops it is 1 TB. Okay, if we talk about the RAMs are always in like GB, either 2 GB, 4 GB, 8 GB, okay, or 16 GB, okay, but not that much higher. Cache memory or in MB. Okay, so what happens? This is secondary memory, that is hard disk. Hard disk is having higher quantity, but it is less costly. It is less costly hard disk. But RAM is, we use very less GB or 5 to you can say 16, 8 and 4, but it is more costly. And in terms of cache memory, it is going to be in MBs, but it is very much costly. And also in terms of speed, the speed will be like increasing. So hard disk is having smallest speed, then the RAM, and above RAM there is a cache memory. Okay, so cache memory is much costly but higher speed. Then secondary memory, that is hard disk, is less costly but lower speed. So that's why when the computer, because the computer is having the speed of gigahertz, speed in terms of gigahertz, when computer is having speed in gigahertz, it should be getting the instructions at that particular speed. Otherwise, it is operating at 1 gigahertz or 5 gigahertz, but the rate of transfer of the data is very less. Like it is able to process the data, but data is not reaching to the computer or to the microprocessor. To reduce that time delay, basically we are having different types of memory stored used. So very near to the microprocessor, the cache memory is there. That is having higher speed comparable to the processor. Similarly, the speed comparability between RAM and cache is quite reduced. Then the RAM and hard disk, there is a very less difference. If we consider the speed difference between a processor and secondary memory, it will be very high speed variation. Hard disk and the processor speed. So to reduce that gap, we are having the RAM and the cache. That will further reduce the speed of speed location where the program is stored and the speed of the processor that is going to operate on a particular instruction. Okay. So here primary storage memories are fast, okay, because it is very close to or closer to the processor. That is fast. And here programs must be stored in memory while they are being executed. So if a particular program is need to be executed, it should be stored into the primary storage memory. Initially, it would be in hard disk. Okay, when it is going to be executed, it should be stored into the RAM, and then from RAM to cache. Then it will be executed with respect to the processor by transferring that into the register. Even beyond this, there is a register. each registers are there into the processor. So processors are having, we have seen. So here, okay, in CPU there is a register. So these registers are having the much higher speed than the cache memory also. Okay, that registers are basically stored into the processor. There are temporary storage devices. Next one is large number of semiconductor storage cells. Okay, so here in terms of like primary storage, large number of semiconductor storage cells are used for designing this cache memory or the primary storage memory. Here the processing will be in terms of words. So based on the type of processor, so suppose a processor is 8-bit, 8-bit microprocessor is there. That means we can call it like, for this processor, one word is equals to 8-bit, or one word is equals to 1 byte. So one word will be equals to 1 byte, because microprocessor is able to fetch 8 bits at a time. If a processor is there that is having a 16-bit, a 16-bit processor is there, that means it can operate on 16-bit at a time. At a time, it can operate on 16-bit data. If a 8-bit microprocessor is there, that means a microprocessor can operate on only 8-bit at a time. Okay. If similarly a 32-bit microprocessor is there, then if 32-bit microprocessor is there, then it can operate at 32-bit at a time. And nowadays it is 64-bit microprocessors are there. Okay, that means it can operate at 64 bits at a time. Okay, so RAM and memory access time. So here basically here in terms of like primary storage memory, if we consider, it is fast and it processes in terms of words. And here in terms of primary memory, it is RAM, and its speed is basically given in terms of like memory access time. So memory access time is going to govern the speed of these memories. And memory hierarchy is considered as like cache memory and main memory. So main memory is considered the RAM. Okay, so cache memory, main memory, and then secondary memory. So secondary storage memory is larger and cheaper. So it is larger in quantity, but it is less costly, or the cheapest one. Okay. So next one is arithmetical and logical unit. So here in terms of arithmetical and logical unit, so most computer operations are executed in ALU of the microprocessor or processor. So here ALU, as the name suggests, arithmetic and logic unit. So ALU is the block of the CPU where all the arithmetic and logical operations should be taking place. So arithmetical operations means addition, subtraction, multiplication, and division. This is arithmetic. And the logical operations are like shift operation or comparison. So all these operations should be done in logical unit. So arithmetic operations are add, subtraction, multiply, division. Okay. So this is a separate building block of a CPU where once instruction is fetched, and once after instruction is fetched, it is decoded. After decoding, the processor will be understanding. So understanding like what that particular instruction is going to tell to operate to the microprocessor. If add instruction is to be executed, after fetching, the microprocessor will be getting the address location and then fetch the instruction. After fetching, it will be doing the decoding. So once it is decoding, going to do the decoding, that once it does the decoding, it will understand like what was this is addition. So microprocessor will be going to know once the instruction is decoded, like that particular instruction was to do the addition. So now the microprocessor will tell the arithmetic logic unit to do the addition. Okay, so the addition will be performed in terms of arithmetic and logic operation, or different operations are there. We will see that operations into the assembly language programming also. So here it loads the operand into memory. First, how it fetches the instruction. So loads the operand into the memory, brings them to the processor, performs the operation in ALU, stores the result back into the memory or retains in the processor. So once the processing is done, it will be returning the result into the memory, or it will be storing into the processor into the temporary register. That temporary register is accumulator. Accumulator is the temporary register to the microprocessor. So here basically it uses the registers and fast control of ALU. So basically here it is like going to control the ALU operations very precisely and fast. Okay, so this is arithmetic and logical unit, a control unit. So basically control unit is all computer operations are controlled by the control unit. So we have already seen the CPU is of divided into control unit and execution unit. So control unit is it is going to fetch and decode the instruction. So we have seen the different building blocks of that control unit also. Okay. So the timing signals that govern the input output transfer are also generated by the control signal. So here these timing signals. So at what particular time, what operation should be done, it is also controlled by the control unit itself. Control unit is usually distributed throughout the machine instead of standalone. That means the control unit is not located at one particular location into the computer system. Control unit governs all around the system. That means it should be connected with each and every component of the control system. Okay, so it is not uh, located at a particular location. It is distributed throughout the system. Basically, the operations of computer is it accepts information. So you already know what computer system different operation does. It accepts the information in the form of program and data through an input unit and stores it into the memory. So it will be storing the data and to a memory and then fetching the information stored into the memory under program control into an ALU where the information is processed. So basically, once it will be storing to the memory, and then whenever it will be requiring, it will be fetching from the memory, then decoding and then doing some operation with the help of ALU. And then once it is processed, it will be storing the data to the memory location or delivering to the output. Okay, so output the processed information through the output unit. Okay, control all activities inside the machine through the control unit. So whenever any operation is going to be performed throughout the computer system, it will be controlled by the control unit itself. So this is the processor data control path. So this is the program control. This is PC. So here, this is the, you can say, different temporary registers of the CPU. Okay, so different registers are there. This is the instruction memory where the address and different instructions will be stored. And here the data, this is data memory. That means where the data will be there, and this is where instructions will be there. So instruction will be having some address, data will be having some address. So by fetching, like here, this is ALU. So ALU should be operating on operand. So operand will be given by these lines. So this line is connected to this register block. Okay, register bank. So register bank is inside the CPU itself. There are different temporary registers are there, or general purpose registers are there. So whenever we want to give some data to the CPU or the computer, we should be putting the data into the registers. These registers will be accessible by the ALU. ALU will be taking the data from the registers, performing some operation. Once it is performing the operation, it will be storing to the data memory, or it can give again to the data. Okay, and here, if particular instruction to be fetched, if instruction is to be fetched, then whatever the address of that instruction is there, that is stored into the program counter, This is PC. That instruction will be fetched, and then with respect to that instruction, once it is decoded, that it will be decoding the data. Operand data will be stored into the registers, and then these registers will be given to LU. LU will be giving the result after doing the particular operation, and then it will be either storing or again using the data with the help of accumulator. Here, accumulator is the temporary storage. Okay. So this is all about the today's class. So we will see the next topic into the next class. So I hope it is understandable to everyone. If any of
Yes, sir.
you, yeah, if any of you have any doubt, you can ask. Or one question from my side. So we have seen like we are having different bits microprocessor. So 32-bit, even the 64-bit microprocessor is there. But just go and search on the net, like, is there any processor that is of 128-bit? Okay, so this is an homework to all of you. Just go and search how many processors are there where 128-bit processors are there. That means its data bit size is 128. If there is no processor, why there is no processor? Why there is no processor having 128-bit? Or if there is any processor with 128-bit data, just name it. If yes, if no, then why no? Okay, so this is the homework for you. So okay, then thank you. I will be closing the class.